With optocouplers, we will be talking about a circuit that is zero crossing detection, a very important circuit in electronic boards. To help you understand what zero crossing detection is for example, in air conditioning it serves to regulate the speed of the internal fan. When you have that normal AC fan with a blue capacitor on the board or a gray one, this zero crossing detection through an optocoupler serves to identify and make it change its speeds. But when we talk about forcers fans, we will be detailing its operation a little more. For now, what I will explain is zero crossing detection, which is a part of the board that I mentioned to you when we were tracking tracks. It works as follows. Again, we have to redraw our famous rectifier. Alternating current. Direct current. And here we have the capacitor. But remember that at this point we will have a fifth diode placed, as it was in the sample circuit. Do you remember? Here we have a fifth diode, as we had in this sample circuit. It is placed as follows. This will be negative and this will be positive. And here is where you will find it. Of course, there are 4 more diodes. At this point, taking as a comparison the negative the electron input, between these 2 points we will have the unfiltered rectification, as we could see in the class that we did the measurement with the oscilloscope. What does this point allow us to do? Let's observe. I will mark with a different color so we can notice it. We will go out from here, jump this, and we will go to a lead. We will jump from this point to here. We pass here and then we go back to the lead. And on this side, we will have a phototransistor. What is this? Precisely the optocoupler. Remember that on this side we are having this. What does it mean? That every time electrons are sent they will pass through the lead and the lead will turn on. And 100 times per second or 120 depending on its frequency, that lead will turn off. That is, during all this time this lead remains on. By here the electrons pass. When this lead turns off the electrons here stop passing. And what is on the other side? On the other side we will find the following. On the one hand we will go to the negative or GND. And on the other hand, we will go directly to the microprocessor, the integrated circuit. And here we go to 5 volts that are already generated by the circuit for everything we have already learned. These 5 volts will come to the microprocessor as long as they cannot go to the negative and a short circuit is produced. In reality, the short circuit does not occur because there is a resistance that may be 1 kilo ohms. We will talk about resistances later. Whenever this is on, the 5 volts will be diverted to the negative. But whenever this lead turns off, this is cut off and these 5 volts enter the microprocessor. It turns off. 5 enter. It turns on. The 5 volts are diverted. As a result of this, exactly at the same time, the microprocessor will receive a pulse of 5 volts, exactly at the same time, that is, here. The microprocessor now knows when the alternating current is crossing 0 of 220, 50 Hz or 110, 60 Hz, whatever, but they know what times cross 0 thanks to this detection. And why do we put an optocoupler? The idea is that what happens here does not damage the delicate circuit of the microprocessor, so that is why an optocoupler is also used, to be able to make a very powerful electrical insulation for any problem that may be in the line. This is how it works. One more detail that we are missing is that at this point, from the positive, we will have a large resistance, because precisely if we are not injecting 300 volts to the lead, then we will have a large resistance that can be of 150 kiloohms, for example. We will see all this on the board now to be able to identify this circuit. If this does not work, for example, it may be that the AC fan stops working. I will show you this same thing on the board. Let's observe and follow up here. From this point, where we have this sample, notice that from here we will go to here, with a high value resistance. In this case it is this. And then we go directly to an optocoupler. This coupler, looked at on this side, is the lead. We can see it down here. Generally on the motherboard where this point is indicated, it indicates the number 1 of the optocoupler, the positive of the lead. This other one that is to inform the switched mode power supply about how much the pulse width has to vary, the lead is placed on the delicate side. In this case, the lead is placed on the side where the zero crossing is generated. That is, when we have to inform the consumption from the microprocessor area, the consumption is informed from the delicate area from where the microprocessor is towards this side. And when we have to warn of the zero crossing from the side of the alternating voltage towards the microprocessor, the lead is placed precisely upside down. We have 2 optocouplers, but in the opposite position. And if we wanted to measure it here, inside the board, we can also do it. We can test the LEDs at these points to see if they are in good condition.